60-kilogram person falls 9.8 meters from a storage building and lands stiff-legged in some mud. The person stops after traveling 0.25 meters into the mud. Determine the force applied by the mud in stopping the person. So, surprise, surprise, I'm going to start by drawing a picture. So I've got a person jumping off a building into some mud, and they drop 9.8 meters, and then they go an additional 0.25 meters into the mud. So initially I have gravitational potential. I don't have any kinetic because I'm not moving, and I don't have any elastic because there's no spring. And at the end, I can think about having thermal energy, or I can also think about the work done by the mud. Either one, it doesn't really matter. And so for my kinetic, so my system is the person, the mud, and the earth. And so initially I have gravitational potential energy, and that converts to friction if I include the mud in the system. If I don't include the mud in the system, then it's work done by the mud. So I know that the energy, potential energy, is mgh. And what we've said before in a previous slide is that the energy done by friction is captured in just the work done by friction. And so this is the work done by friction, which is the force of friction times the distance over which friction is applied. So I'm just going to rewrite this up here. So I've got mgh is force of friction times d. My mass is 60 kilograms, and g is 10 newtons per kilogram, and the height that I'm falling is 9.8 meters. And then my friction force is what I'm looking for, and the distance that the friction is being applied over is 0.25 meters. So on the left side I have 5,880 joules, and that is equal to the force of friction times 0.25 meters. And so the force of friction is going to be 5,880 joules divided by 0.25 meters, and that is going to be 23,520 newtons, because remember, a joule is a newton meter. And I can pull my bars all the way up. I know that's 5,880 joules, and this one is 5,880 joules.